we're going to take a look at how to take the derivative of exponential functions. Actually, more specifically, we're going to take a look at the derivative of exponential functions where the base is the natural base, or e. So we're going to take a look at functions that look like this, like e to the x. So the good news is we're really just going to be using two rules today. The derivative of e to the x is about the easiest derivative that we have, because the derivative of e to the x is e to the x. Now, that's about as easy as all of our derivatives are going to be. However, like always, we do need to see what happens if we have to use the chain rule. So again, here I'm using u as some function of x, so this would be like e to the x squared plus 5 or something. So how do we take the derivative of that? Well, the rule says we get that same exponential back, but then always we have to multiply by the derivative of the inside. In this case, the u is inside the exponential. So let's just do a bunch of these and see how they work. Find the derivative. And let's say we got y is equal to e to the 5x. Excuse me. All right, if we're told to find the derivative here, so let's see. Of course, on this side, that gives me y prime. We know the derivative of an exponential. Now, since that's just not x, we have to use our chain rule. We know we're going to get the same exponential back times the derivative of the exponent. The derivative of 5x would be 5. Now, we generally write numbers in front of exponentials, so a lot of times we'll write this as 5e to the 5x. Or let's see, let's say we have something like this. Let's say y is equal to e to the 2x squared plus 3x minus 4. All right, so that's e to the 2x squared plus 3x minus 4. Now, if we're told to find the derivative, so y prime, or dy dx, you get the exact same exponential back. So it's going to be 2x squared plus 3x minus 4. But then you have to multiply by the derivative of the inside, or the derivative of the exponent. The derivative of that exponent would be what? 4x plus 3. All right, you can leave it like that, but again, we generally write things in front of our exponentials. So I'm going to write this as dy dx is 4x plus 3 times e to the 2x squared 3x minus 4. There we go. So how do we take the derivative of an exponential? Same exponential back times the derivative of that exponent. All right, let's try another one. What if I said g of x was 1 over e to the 5x? Now, if we're told to take the derivative of this, unfortunately, it doesn't really fit either one of these, because these have e's in the numerator, not in the denominator. Well, just like when we were doing polynomial type stuff, and where we just had x's or whatever letters we were using, we need to rewrite it so it looks like one of these two. Well, we can bring this up to the top, and we know if we bring something from the top to the bottom, or the bottom to the top, the exponent changes sign. So I can rewrite that as e to the negative 5x. Now it fits this form right here. So we can take the derivative of this. So let's see, g prime of x. When we take the derivative of an exponential, we get the same exponential back times the derivative of that exponent. The derivative of e to the negative 5x is negative 5. Now, there's a couple of different ways we could write this. Like I said, generally we write the numbers out front. It's going to be 5. All right, so there's not a bad way to write it. However, it has a negative exponent, and the book may also express it like this. Negative 5 over e to the negative 5x. Either one of those last two would be perfectly fine. In fact, this one's actually a little smaller to write, so you may want to write it like that. Okay, so that's it. That's about as difficult as taking the derivative of an exponential gets. You get the same exponential back times the derivative of the exponent. Now, just because we have a new rule doesn't mean all the old stuff goes out the window. So our directions, even though I just erased them, I'll put them back up here, are just find the derivative What if we said y was x squared e to the 4x? All right, by looking at this, we can't put this into either one of the forms we have, and now we have x squared times our e to the x. Well, we saw in the past, anytime we have two functions multiplied together, we'd want to do our product rule, right? Remember here we have multiplication right there. Now the way that we did this so far was we called one function u and the other function v. So if I let u be equal to x squared and v be equal to e to the 4x, I need to find the derivative of each one of these. So the derivative of x squared is 2x, v prime would be e to the 4x times 4, or 4e to the 4x. Now remember our product rule, it's u prime v plus v prime u. So our derivative, y prime, u prime times v, so that's 2x e to the 4x plus v prime times u. So I do x squared times 4e to the 4x. We generally write our numbers first. So 4x squared e to the 4x. All right, so anytime we introduce a new rule how to take a derivative, doesn't mean our old stuff goes away. You still might have to do the product rule and, let's say, the quotient rule. Let's take a look at one that maybe have the quotient rule in it. What if I say f of x is equal to 1 plus e to the 2x all over x squared plus 5? Ooh, ugly. All right, so since we do have a quotient here, we would do same idea that we did with our quotient rule. We'd call the top u, the bottom v. And we go over to the side, we say u is 1 plus e to the 2x. V is x squared plus 5. So the derivative, let's see, the derivative of 1 is 0. The derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. So I'm just going to go ahead and write that out front. V prime, well, that's just 2x because the derivative of 5 is 0. Now remember, our quotient rule is u prime v minus v prime u all over v squared. So our derivative, or f prime of x, let's see, what do we say? U prime times v. So 2e to the 2x times x squared plus 5 minus v prime times u. 2x, 1 plus e to the 2x. All divided by v, x squared plus 5, quantity squared. All right, I'm going to leave it right here. You're probably going to want to, most of the time here, distribute out the top and combine like terms. I just wanted to put the pieces together for you. All right, moving along, let's take a look at, again, some other rules that may come into play. What if I said, I don't know, y is equal to the square root of e to the 3x plus x squared? Okay, how are we going to take the derivative of this? Well, we always have to use our chain rule, and I see we have this function stuff inside the square root. So I'm going to go ahead, before I take the derivative, and write that square root as the 1/2 power. So to take the derivative here, so y prime, or dy dx, bring down the power, copy the inside, take one away from the power, multiply by the derivative of the inside. So now I'm just looking at this piece right here. So derivative of e to the 3x, well, we know we're going to get an e to the 3x back, times the derivative of the exponent. The derivative of 3x is 3, and I'm going to write that out front, plus the derivative of x squared is 2x. All right, I am going to take one more step and clean this up. So let's say we have dy dx is equal to, since I have negative exponents and fractions, I'm going to think about this whole thing as a fraction. We have a 2 on the bottom, of course a 1's on the top, you can write that if you want. This has a negative exponent, so it goes down to the bottom, then its exponent becomes positive. All of that has a positive exponent, so that stays on the top. Now the book here may, and I don't care if you do it or not, may rewrite this 1/2 exponent as the square root symbol again. I don't care. You can write the square root there instead of the 1/2 power or the 1/2 power. Okay, so you see all of our old rules come into play. We're just mixing a new rule into the into the group. All right, let's see one more thing that might show up. Let's make it, what if I said, find the second derivative. Now remember, finding higher order derivatives is just taking more derivatives, so there's no new rules here. So let's say if I gave you the function y is equal to, let's go 2x cubed e to the 5x. That should be ugly. Okay, so here if we're going to take the first derivative, again we have a function times a function, so we're going to want to use our product rule. So I'm going to call my first function u, which is 2x cubed, and my second one v, e to the 5x. So if I say u is 2x cubed, v is e to the 5x, u prime, let's see, bring down the power, take one away from the power. Derivative of an exponential, you get the same exponential back, times the derivative of that exponent. The derivative of 5x is 5. So y prime, or dy dx, whichever notation you're using here, is going to be u prime times v. So 6x squared e to the 5x plus v prime times u. So when I multiply these two together, I get a 2 times a 5, which is a 10x cubed e to the 5x. Okay, there's our first derivative. Now we need to do the second derivative. So here we have two things we have to take the derivative of, and notice for both of these, we're going to have to do the product rule for both. So we got a lot of writing to do here. So let me see, for the first one, I'm going to use the same letters. You can change these up if you want. U and this for V. So for our first term here, we said u was 6x squared, v was e to the 5x. So u prime is 12x and v prime is, well, we just did it, 5e to the 5x. For this piece, u is 10x cubed, v is e to the 5x. U prime is 30x squared, and v prime again is 5e to the 5x. All right, so these are the pieces we're going to use for the derivative of the first one. These are the pieces we're going to use for the derivative of the second one. I'll make myself just a little bit more room. So my second derivative, so using the same notation, d squared y dx squared, too many equal signs, equals. Okay, so for this one, it's going to be u prime times v. So I have 12x e to the 5x plus v prime times u. So 5 times 6 is going to be 30x squared e to the 5x. Okay, so for the second one, that's the derivative of our first term. The derivative of our second term, u prime times v, gives me 30x squared e to the 5x plus v prime times u. Again, I'm going to multiply those numbers together. So 5 times 10 gives me 50x cubed e to the 5x. Okay, so the first two pieces came from the derivative of the first term. The second two pieces came from the derivative of the second term. Now notice in this case, we do have some like terms that we can combine. So the second derivative of y with respect to x is 12x e to the 5x. Here I have 30x squared e to the 5x's, another 30x squared e to the 5x's, so I have 60x squared e to the 5x, and then 50x cubed e to the 5x's. Okay, so there is the second derivative. Now if we had to do the third derivative, well, it'd be messy because we'd have to do the product rule for all three of those terms. It'd get pretty big and pretty ugly. All right, so we have a new rule how to take the derivative of an exponential. How do you take the derivative of an exponential? You get the same exponential back times the derivative of its exponent. So a very simple rule, but it's going to be mixed in with all the other stuff that we have learned up in and out, which is going to make it a little bit more difficult.